Assalamualaikum, I am Muhammad Nur Iqmal, and today I will be presenting about problem statement, objective, scope of project, and organizational chart of our integrated design project. Firstly, problem statement. Problem is, Malaysia is continuously promoting effective waste management. Based on research or case study on waste management practice, in masjid are lacking. Enormous amount of solid waste in masjid is due to anthropogenic activities and contribute to increment of waste. So the solution of our problem is to develop an effective masjid waste management system using Internet of Things. Then by the system, an incentive or reward scheme would be incorporated into the system as a way of promoting separate waste and green masjid practice. By this, it will encouraging domestic practice in segregating and recycling of waste will be better approach toward an integrated sustainable waste management system in Malaysia. So our objective is to analyze the effectiveness of smart dustbin in the existing system in promoting separate waste and green masjid practice. Then to develop a smart dustbin using the Internet of Things and reward scheme into the system. And the third objective is to encouraging domestic practice in segregating and recycling of waste. In this project, to achieve the objective, firstly, this project needs to identify an effective most waste management system using the Internet of Things. From research and journal, this project will develop a smart dustbin with a reward system to promote separate waste and green moss practice. To promote separate waste and green moss practice, this project will be using Internet of Things component that is Arduino Uno, servomotor, and ultrasonic sensor. For the reward scheme system, we will be using Google Form to keep information and points of the user. In the Google Form, we will monitor user activity based on the frequency using the smart dustbin to give a push notification message if the user has complete points to claim the reward. This project also has a limitation with its coding program. This project is carried out by using limited coding programming. So, when the project is using limited coding programming, the project is lack of idea in improving the performance of the smart dustbin.
Hi, Assalamualaikum. My name is Muhammad Aziz bin Karnwa. So today I would like to present about our market analysis. For the 5.1 customer requirement, we were using a Google Form to conduct our survey. The reason why we're using a Google Form is because it is very user-friendly and very easy to use. We were handing out our link through the WhatsApp. So there's a total of 50 respondents. And there's a total of 4 parts of our survey findings, part A, part B, and also part C and D. As of the part A of our survey, we were asking about our respondent background such as gender, age, and occupation. Most of our respondent is at the age of 18 to 25 years old, and 62% of them is a full-time student. As for the part B, we were asking the question of this section consists of respondent knowledge towards Arduino in the smart dustbin. We were asking, are you familiar with Arduino? Have you ever heard of smart dustbin before? And also, do you feel ever disgusted when opening the dustbin? And you can see all in the figure. So as for the part C is the most important part because it related to our HOQ. For part C, we were asking a question is what is the type of characteristic for our smart dustbin? First, the size, the price, design, durability, and also the weight of the dustbin. And we were asking also the prefer dustbin with roller or not, have a cover or not, and also a material of the dustbin. As for the part D, we were asking their opinion about our product, the benefits toward our society. So we were asking, do you think that smart dustbin with a reward system will be a good idea? Do you believe we will be able to persuade people to throw rubbish in a smart dustbin that we made? Do you believe we can reduce the amount of trash surrounding the masjid if we install a smart dustbin with a reward system? So this is our HOQ. If you can see here, this is all based on the part C that we made. And as for the last is engineering specification. The size of our dustbin is at 200 millimeter times 310 and times 240. As a specification, Arduino will keep an eye out for anything that comes within a certain distance of the sensor. Object is detected by ultrasonic sensor and the dustbin cover will automatically open. As for the metric, the cover will automatically open for 4 seconds until it closes for itself. So I think that's all for me today. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adam Aiman bin Mandut. For my part, I will explain about the conceptual design and selection. Firstly, the morphological chart. The morphological chart is a method to generating ideas in analytical and systematic way. On the left side of the chart, the functions are listed, while on the right side, alternative methods that can be used to carry out the functions are depicted. It is a tool that helps in the generate of fresh ideas. To construct single systems, various mechanisms indicated in the morphological chart are combined to form ideas. It is suggested that for each concept, a variety of feasible designs be created using different methodologies for each function. Based on the morphological chart, a combination of circle-shaped ultrasonic sensor without wheel and plastic material is the best solution for the smart bin. This combination demonstrated that the smart bin concept is similar to the usual dustbin, but with the addition of the Internet of Things, which made people easier to use and get reward from throwing the trash in the smart bin. The light material is plastic. Furthermore, with low-cost materials, plastic can generate an excellent product. Next is the concept design. Our group have came out with 5 different designs. After that, we have a concept screening. This concept obtained from the morphological chart, then tested against 5 major standards as well as customer requirement. So, for the customer requirement that we see from this table is functionality, eco-friendly, repairability, cost of production, expected life of product, and safety aspect. This is decision matrix that is used to choose which concept will be studied further. The symbol can be used to symbolize 5 different relative performance as illustrated in table. By counting the number of plus or minus, each design received the total finding. Finally, the total number of plus was subtracted from the net score of minus to arrive at the final result for each design. After that, from the table, we see that 2 ideas design were rejected and 3 were chosen. According to the table of screening above, the 3 concepts that have been accepted will move on the next round, which is concept scoring. Last but not least is the concept scoring. The concepts that have been chosen after the concept screening technique are used for concept scoring. The table shows the rating system employed, which is based on a -3 to a +3 scale. As the number reduces, the likelihood of the design failing to match the criteria increase. For essential design criteria, the weight scale means a higher score. The overall score was calculated by combining all the weight scores for each concept. The three best design will be chosen from those with the greatest total score. And for the result of the path chart, the concept design 1 was the one that best met the design criteria. The concept 1 was chosen because it had the maximum value among concept design 2 and 4. Design 1 was chosen because it is straightforward and easy to use for everyone as to design 2 and 4. It can place it anywhere and people will be able to easily recognize the smart bin as the usual bin. And that's all for me. Thank you.
My name is Muhammad Izwan. So I'm going to explain on the functionality of the product. This product selected called Smart Bin by our company, which is SmartTech. This product is incorporated an incentive or reward scheme as a way of promoting separate waste and green masjid practice. This product is designed to support the segregation process in line with the Malaysian 12 Plan. Prevention at the source by encouraging domestic practice in segregating and recycling of waste will be a better approach towards an integrated sustainable waste management system in Malaysia. How does it work? When the device is turned on, the Arduino will monitor everything that comes within a specific range of the sensor. When an ultrasonic sensor such as a hand or other object is detected, the dustbin cover will automatically open using a servo motor. We will attach a QR code at the bottom of the dustbin lid so that our clients may claim or redeem the rewards whenever they throw the trash in the bins. For the components of the product, our product consists of 3 main components, which is Arduino Uno, the Pro servo motor, and ultrasonic sensor. For Arduino, the Arduino software is known as Sketch, and it must be loaded into the board. The Sketch is nothing more than a collection of instructions that allows the board to perform certain operations based on your specifications. The Arduino is a low-cost, flexible, and easy-to-use programmable open-source microcontroller board that can be integrated into a variety of electronic projects. For a tower servo motor, the servo acts as an arm of this smart bin as it can vary pulse with modulation signal duty cycle, rotates the arm head of the servo motor. Servo arm head can rotate from 0 to 180 degree. This motor can easily rotate the servo arm from 0 degree to a fixed angle between 0 to 180 degree and then back to the 0 degree. For the ultrasonic sensor, an opening detector will be installed on the trash lid to get statistics on garbage use and detect bed closure. This sensor is placed in front of the bin and detect any movement.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nazrul Hakimi bin Saha, and today I'm going to present product analysis of our smart dustbin. Our product analysis consists of three analyses, which is number one is ultrasonic sensor analysis, number two is cost analysis, and number three is von Mises stress analysis that we simulate at SolidWorks. We go for number one. Our ultrasonic sensor analysis is to determine the measurement our distance of how our sensor and how far our sensor can detect, and we find out that our ultrasonic sensor can detect to 2 centimeter until 400 centimeter of echoes, and we use of HCSRCO4 type of ultrasonic sensor in our smart dustbin. And our cost analysis is our Arduino Uno costs 30 ringgit and our servo motor costs 8 ringgit 80 cents, and our ultrasonic sensor costs 3 ringgit and 40 cents, and our thread cost of 80 cents, and our dustbin costs 8 ringgit 50 cents, and our battery costs 17 ringgit, and our cardboard costs 4 ringgit and 50 cents, and our jumper cable cost of 7 ringgit, which means total price of our costing of our product is 80 ringgit, which means we divide by 6 is 14 ringgit. Von Mises stress analysis. The von Mises yield criterion state that if the von Mises stress of a material under load is equal or greater than the yield limit of the same material under simple tension, then the material will yield. This is the meaning of von Mises stress. We simulate our smart dustbin by using von Mises simulation in SolidWorks by putting 45 Newton, which is equal to 5 kilogram of rubbish insert. And we find out that our limit of fracture is between 5.462 times 10 power of 3 Newton meter square until 1.258 times 2 times 10 the power square of 4 Newton meter square. Any rubbish from outside that exceed this number of von Mises stress value, it will make our smart dustbin fracture, explode, or broken. That's all from me. Thank you.